Hello friends, in this video we will look at SortedSet Interface and the implementing class TreeSet. So TreeSet is kind of a collection of uniqueness over a balanced tree. So first let us look at Java's SortedSet Interface. Java TreeSet implements SortedSet Interface. The sorted set is derived from set interface. So since TreeSet implements sorted set interface, we can access all the set functionality in TreeSet. So we will get the functionality of sorted set as well as set in the TreeSet implementation. We already saw an example of set interface functions in the HashSet demo. So in the previous video we explored about HashSet. HashSet implements only the set interface. It doesn't implement TreeSet interface. So whatever functionality, the set functionality available in HashSet is also available in TreeSet. So in addition, we will get the functionality exposed by the SortedSet interface. SortedSet implementation performs elements ordering. So we already know that the set interface asks the implementer to maintain the element uniqueness. So SortedSet is derived from set, and SortedSet asks you to keep the element in a specific ordering. It can be ascending order or descending order. So since SortedSet is derived from set interface, the implementing class should order the elements, and at the same time it should maintain the uniqueness. Since SortedSet sorts element, it needs to know how to compare two elements. So it's not comparing, it's not saying that whether two objects are equal. It's kind of comparison. Comparison in the sense you will get three kind of outcome. One is both the elements are equal, and if it is not equal, then let's say element E1 and E2 are equal, or we will end up with E1 is lesser than E2 or E1 is greater than E2. So the compare method will tell these three kind of variation in terms of the return value. So there should be a way to compare. That's what here we want to say. So the TreeSet should know how to compare two elements. If you are storing whatever you are storing as a element, that needs to be comparable. Java types like a string or boxed primitive types like integer, double, boolean. So all those inbuilt classes implements comparable interface. So if we want to store our own element, like previously we saw about the product class, right? So if you want to store the product class, then Java doesn't know how to compare to product. So during that time, we have to tell how to compare to product by implementing this comparable interface. So we will learn about comparable interface in a separate video. Here we are going to look at the basic functionality of the TreeSet. So simply speaking, we are going to dig into the functionality offered by the SortedSet interface and those functionality which is implemented in TreeSet, and we will access those functionality and we will produce a Eclipse demo here. The below table lists frequently used methods of sorted set. Since the implementing class of this SortedSet interface already sorts the element, when you make a call to first, the element will return a first element in the sorted list. Now let us say the elements are sorted in ascending order. So if that is the case, the first element will be the lowest of the element present in the sorted set. So if it is in descending order, then the first will give the highest element. So it depends on the sorted order. But first will pick the first element in the sorted set. Alright, so the last will pick last element in the sorted set. So based on the sorting order, you will either get highest or lowest element. So for simplicity's sake, let us consider the element is sorted in natural sorting order. Natural sorting order in the sense, if it is numbers, then it will be 1, 2, 3, 4, 5 like that. And if it is alphabets, it is from A to Z. And if it is alphanumeric, then the sorting in natural sorting order will go like A1, A2, A3, B1, B2, B3, C1, C2, C3, and so on. Alright. The headset method will take a parameter of element that is stored in the sorted set, and when you make a call to headset, it will return a subset of the sorted set. So the subset ranges from the element which you pass and the head element. So the range will be from head to the element that you pass to this headset parameter. So let us say that the set is arranged in natural sorting order. Then if you make a call to this method, whatever the method returns, those elements are lesser than what you passed here as parameter. The tailSet will return again a subset. The return type is sorted set. It returns a subset, and the subset range from the element that you pass here from towards the right hand side, and it goes till the tail end. So if the elements are sorted in the natural sorting order, then you will get all the elements which are bigger than the element that you passed here as a parameter. That means all the elements are greater than the from element. Then there is a function called a subset, and that will also return a sorted set. But instead of head and tail, here we will be passing two elements, E1 and E2. So whatever elements is returned, that will be returned between these two range. So the range is fixed by from and to. TreeSet is the implementation class of the sorted set. There are a lot of other classes, but here we are going to concentrate on TreeSet. TreeSet is a collection class which implements both set and SortedSet interface. The set interface functionality we already saw in the hash set. So the hash set implements only the set interface. So here when we are using the TreeSet, we will explore the SortedSet functionality. Whatever we saw in the previous slide, we will explore those functionality when we are going to the Eclipse demo. So the TreeSet implements both set and SortedSet interfaces. The elements are unique and sortable. Unique, so that's from the contract of a set interface, and sortable, that is from the contract of a SortedSet interface. So when we add elements to our TreeSet collection class, automatically the elements are unique. That means duplicates are not allowed, and the elements are sorted by default in natural sorting order. or in some other sorting order which is customized by the user. But the elements are sortable, so that's the gist out of it. The operations contains add, remove will perform well with the log n execution time. Here n is the number of elements which is currently available in the tree set. So we know the formula of log n, right? Log 10 is 1, log 100 is 2, and log 1000 is 3. So if the base is 10, so that means, so if 10 elements take 1 second, 100 element will take 2 seconds, and the 1000 element will take 3 seconds, and you can see the performance here. So the real performance benefit you will see when number of elements are high when compared with array list or a linked list. The elements are stored in binary tree format to achieve this log n execution time for the methods contains add and remove. We will learn about binary tree in some other video. For now, we just know that the underlying data structure for the tree set is a binary tree. The tree set of Java takes care of balancing the binary tree. So balancing also we will see in some other video when we are discussing about how Java forms the binary tree. That time we will also learn how it is balancing the binary tree and what is the need for balancing a binary tree. Alright, now it's time to explore TreeSet in Eclipse, and we will explore the basic functionality of SortedSet. So remember, the TreeSet also supports the set functionality, and the set functionality is already explored in the previous video when we are experimenting the hash set. Alright, let us go to our first test run. Here what we are going to do, we are going to create a tree set, then we will add elements and print it. So first we will add the required packages and classes. So the iterator is an interface. This is to iterate the sorted set. So the sorted set is an interface, and TreeSet is the implementation class of this sorted set interface. So the iterator will be retrieved from this TreeSet, and we will iterate over the TreeSet. So that's why we included all this. Next, we create a TreeSet. Here, if you see, the TreeSet is created, and it is created over an integer. That means in this TreeSet we can add only the integer. In the left hand side, the object is referred by a SortedSet interface, and it says the SortedSet is over the integer type, and the reference is a set. So now using this set reference, you can call all the SortedSet functionality as well as the set functionality. Why? Because a SortedSet is derived from set interface. So we can make a call to both set and SortedSet interface functions. Next, what we are doing, we are adding some sample integers. We are adding it in a different order: 4, 5, 8, 9, 2, 3, 6, 0, 1. The reason for adding this in a different order is when we are retrieving the iterator over the tree set, and when we print, we will get the result in a natural sorting order. That means we will get the result as 0, 1, 2, 3, 4, like that. So here the insertion order is different. So the underlying data structure will sort these element during the insertion itself. Alright, finally here we are having a function print tree. It's a private static function and it returns nothing. So it takes a sorted set integer as a parameter. So that's what here, right? Sorted set. And the parameter name is set here. So inside the function we are taking the iterator, and now the iterator know how to traverse the underlying data structure. So in the slide we saw that the underlying data structure is the binary tree, right? So you no need to worry about how to traverse that binary tree, because the iterator which we retrieve here will take care of how to traverse the tree. So the internal algorithm, we may not know. It may be a recursive call, or it may be retrieving the items through the stack operation, push and pop. Alright, so let's at this stage we no need to dig into it. So we retrieve the iterator, and the iterator knows how to iterate over the underlying binary tree structure, and it will retrieve the value during the each iteration. So since it's a iterator, we already saw how iterator works. So we make a call to hash next. When it returns true, we take one element. Here we are taking iterator.next and we are passing that to the print function. That means it will return the integer during each iteration, and we will print that. So now when we are iterating this, the iterator will get the element from head to tail. So when it takes, since it is a sorted set, the elements are already in the sorted order. So when we take move from left to right, we will get the elements which is already placed in the natural sorting order. Alright. Also one more point here, since here we are adding the integer type. Integer means here it is not a primitive type, it's a integer object, it's a boxed value, and this integer class already implemented the comparable interface. So our TreeSet knows how to compare to integer. That's how it placed this integer in the natural sorting order. Alright, here we create the iterator, and then we are iterating over it, and we are printing the element during each iteration. Next, in the fourth step, we are just making call to this print tree, and we are passing our set interface reference. So we already created a tree set. We added element, then we wrote a function to iterate over this sorted tree set. After that, we are making call to that function. Now we will add this code one by one in Eclipse. First we added the import statement, then we add our tree set creation and adding the elements. So we are adding that inside the main. Then we add our print tree function. Finally, we make a call to our print tree. Alright, now we will place a breakpoint here, and you can see how it is sorting when we are adding the elements. So here first we are creating our tree set, and let me place my cursor here so that you can see how the elements are added and at the same time how they are sorted. So first we are adding element 4. Remember, this is an integer and it implements comparable interface. Comparable interface compares the element in a natural sorting order. That means the order is in ascending order. So first we are adding element 4. 4 appears first. Next we are adding 5. 5 goes next to 4. Now we are adding 8, so it goes next to 5. Then we are adding 9, it goes next to 8. Now we are adding element 2. So since it's in the natural sorting order, now element 2 goes before 4. Then we are adding 3. It will go between 2 and 4. Now 6, 0, and 1. So if you see here, the element 7 is missing here. So we purposefully missed it. So later when we use contains method, that will come handy. Alright. Next we are printing the tree. So we no need to debug it since we already saw how these iterator work in the previous videos. So now when I step over it, it will print whatever you see here. So just printed the elements in the natural sorting order. If you see here, the insertion order is different, right? 4, 5, 8. But when we print, it printed it in the natural sorting order. Now we will go to our second test run. Here we are going to get first and last element in the tree. So if you see here, for example, if we take first element, it will return 0, and if we take last element, it will return 9. Since the elements are already placed in the sorted order, when we take the first element, it will be the lowest of all the elements, and if we take the last element, it will be the highest element when the order is a natural sorting order. Alright, now we will just explore the function first and last. So we are returning the first element and it will be 0. Then we are returning last element, that will be 9. Then in our third test run, we are going to take element which is lesser than the supplied element. Then we are going to take all the elements which are greater than the given element. We will also see how to print element between the range E1 and E2. So these functionalities are possible when the elements are already sorted. So here the elements are already sorted, so the task will become easy now. So the method is headset, and for headset we are passing 5. So after that we are making call to tailSet and we pass the same 5. Then we make call to the subset and we pass a 2 parameter 3 and 8. Let us see how it works. So here we are calling headset, right? Headset means from head it will go to element including or excluding 5. I don't want present. Let us execute and see. But whatever element returned, that will be less than or equal to 5. So it depends whether it includes this 5 or not. Let us see that. So we have a head set, and if you need, you can place a cursor here. So it is not including 5. So whatever element it returned, it's a subset, and the elements are included from head till this element 5, whatever we passed. So when we print that, we will print 0, 1, 2, 3, 4. So print tree will do the same job, and it will print 1, 2, 3, 4. Next, what we are doing, we are calling tailSet. That means from here towards the tail. So that means this time it will include 5, and it moves towards the tail. So whatever element we get, that will be greater than or equal to 5. Now let us present the execution stays at this line, and if I execute this line, it will return the tailSet. And if I place a cursor, and you can see the element 5, 6, 8, 9 is included. So when we print, we will print the same content here, 5, 6, 8, 9. Next, we are making call to subset. So 3 through 8. Let us see what it returns. Subset, and if I click subset, it returned 3, 4, 5, 6, and 8 is skipped. That means the 2 element is skipped. From 3, it picked the element and it moved just before the element which is passed as second parameter. That means the 2 element is not included. So that's how here the range of element we picked and we printed that. So that's the use of a subset. And when we print the tree now, because this time if you see here for the print tree, we passed the head set, here we passed the tail set, and now we are passing the subset. Since we are passing the subset, the content of subset is this, and the TreeSet will iterate over this subset and prints the content. So the content is 3, 4, 5, 6. Alright, let's go to the last part of our test run. Here we are making use of the contents method, and if you remember, this contents method is the contract of a set interface, not a sorted set interface. But subset, tailSet, headset, all these are sorted set interface function, first and last even. Alright, now let us explore one of the set interface functionality. Here we are searching for a specific element, and this search is more efficient. We will see it in a separate video. Now we will copy this. Let's move our breakpoint towards the code snippet 9. So first we are checking element 5 presence in the set. So set in the sense we are using this set. So 1 to 9, that's the set content. First we are checking whether 5 is present, so this will return true. Next we are checking 7 is there, 7 will return false. Since we are appending that here with the print line statement, so in the print line statement we are making call to the set contents, and we are appending that with the string content. So it will print the boolean result directly in the output. Now is element 5 present? True. That means the boolean is converted to string and it prints true. Is element 5 present? True. Means the search already confirmed that the element 5 is part of our sorted set. Now 7 is there. So when we created, we skipped setting the value 7 here. Now we are checking that. So tailSet This element 7%, it tells false. So this way you can compare whether a element is present in a tree set or not. So since it operates on binary tree, this search will be very efficient when compared to array list or linked list. So now we are clearing the element, it will become empty. So this clear also part of the collection interface function, or it's available through set interface. That's all here in this video. Thank you for watching. If you like the channel, subscribe it. Bye.